Welcome back to AI Explains Everything, the video series where we use artificial intelligence to explain complex concepts. In this episode, we'll be exploring the exciting world of natural language processing, one of the most fascinating and challenging areas of artificial intelligence. So, what is natural language processing? At its core, natural language processing, NLP, is a branch of artificial intelligence that focuses on enabling machines to understand, interpret, and generate human language. NLP is used in a wide range of applications, from chatbots and virtual assistants to sentiment analysis and language translation. One of the most important tasks in NLP is natural language understanding, or NLU, which involves breaking down human language into its component parts and extracting meaning from those parts. Some of the key techniques used in NLP include text preprocessing, part-of-speech tagging, named entity recognition, sentiment analysis, and language modeling. Each of these techniques plays an important role in enabling machines to process and understand human language. Text preprocessing involves a series of tasks that transform raw text data into a format that can be easily processed by machine learning algorithms. This is often necessary because natural language text data can be messy and unstructured, making it difficult for algorithms to work with. The first step in text preprocessing is often tokenization, which involves splitting a sentence or paragraph into individual words or tokens. This is important because many NLP algorithms work at the word level rather than the sentence or paragraph level. Tokenization is often followed by lowercasing all words, which can help reduce the vocabulary size and make the text more consistent. Next, stop words may be removed, which are common words like the, or, and, that don't carry much meaning. Stemming or lemmatization may also be applied to reduce words to their base form. Finally, the preprocessed text data may be transformed into a numerical format, such as a bag of words representation, where each word is represented by a count or a frequency in the text data. Part-of-speech tagging, POS tagging, is the task of labeling each word in a sentence with its part of speech, such as noun, verb, or adjective. This is an important task in NLP because it can provide useful information about the grammatical structure of a sentence. POS tagging is often performed using machine learning models that have been trained on large annotated datasets. These models may use a variety of features, such as the word itself, the context of the word, or syntactic features like dependency relationships. Named entity recognition, NER, is the task of identifying and extracting named entities from text, such as people, places, and organizations. This is a useful task for many applications, such as information retrieval or event extraction. NER can be a challenging task because named entities can take many forms and can be expressed in many ways. Some common approaches to NER include rule-based systems that rely on patterns or regular expressions, and machine learning-based systems that learn to recognize named entities from annotated data. Sentiment analysis is the task of determining the overall emotional tone of a piece of text, such as whether it is positive, negative, or neutral. This is a useful task for many applications, such as social media monitoring or customer feedback analysis. Sentiment analysis can be performed using a variety of techniques, including rule-based systems, machine learning-based systems, and lexicon-based systems that rely on predefined lists of positive and negative words. Language modeling is a task that involves predicting the probability of a given sequence of words. This is a key component of many NLP tasks, such as speech recognition, machine translation, and text generation. Language models are often trained using large amounts of text data, such as books or web pages, and can be used to generate new text by sampling from the model's distribution over words. In addition to these techniques, there are many other important tasks and subfields in NLP, such as parsing, machine translation, and information extraction. NLP is a rapidly advancing field with many practical applications, and there is still much research to be done to improve the accuracy and efficiency of NLP algorithms. Parsing. Parsing is a fundamental task in natural language processing that involves analyzing the structure of sentences and determining the relationships between their constituent parts. This process involves breaking down a sentence into its component parts, such as nouns, verbs, adjectives, and other grammatical elements, and then using this information to determine the relationships between these parts. There are two main approaches to parsing: rule-based parsing and statistical parsing. Rule-based parsing involves using a set of predefined rules to parse sentences. These rules are typically based on formal grammars such as context-free grammars, which define the syntax of a language. Rule-based parsing can be very accurate but requires a lot of manual effort to create the rules and maintain them as the language changes. Statistical parsing, on the other hand, involves using machine learning algorithms to learn the patterns and structures of language from a large corpus of annotated sentences. This approach is more scalable than rule-based parsing and can handle a wider range of sentence structures and languages. However, statistical parsing can be less accurate than rule-based parsing for languages with complex grammar and syntax. Machine translation. Machine translation is the task of automatically translating text from one language to another. This task is challenging because language is complex and often ambiguous, and there are many different ways to express the same idea in different languages. There are two main approaches to machine translation: rule-based machine translation and statistical machine translation. Rule-based machine translation involves creating a set of rules that govern how words and phrases are translated from one language to another. These rules are typically based on linguistic knowledge and are manually created by linguists and language experts. Rule-based machine translation can be very accurate but requires a lot of manual effort to create the rules and maintain them as the language changes. Statistical machine translation, on the other hand, involves using machine learning algorithms to learn the patterns and structures of language from a large corpus of parallel texts. This approach is more scalable than rule-based machine translation and can handle a wider range of languages and translation tasks. However, statistical machine translation can be less accurate than rule-based machine translation for languages with complex grammar and syntax. Information extraction. Information extraction is the task of automatically extracting structured information from unstructured or semi-structured data sources such as text documents, web pages, and databases. The goal of information extraction is to identify and extract specific types of information, such as named entities, relationships between entities, and events. There are several techniques used in information extraction, including rule-based methods, statistical methods, and machine learning methods. Rule-based methods involve creating a set of rules or patterns that specify how to extract the desired information. Statistical methods involve using machine learning algorithms to learn patterns and structures in the data and then using this knowledge to extract the desired information. Machine learning methods involve training a machine learning model on a large dataset of labeled examples and then using this model to extract information from new data. One important application of information extraction is named entity recognition, NER, which involves identifying and classifying named entities in text, such as people, organizations, and locations. Another important application is relation extraction, which involves identifying and extracting the relationships between named entities in text, such as the relationship between a person and a company or between two people. And that's it for our overview of natural language processing. We've discussed some of the key techniques and applications of NLP, as well as some of the challenges that still need to be overcome in this field. In the next episode of AI Explains Everything, we'll be exploring the fascinating world of computer vision. Thanks for watching, and we'll see you next time.